Hi, Ruth. Welcome.
Hi, Crystal. Thank
So
you.
first off, thank you truly for really taking the time to be here with me tonight and to really, as we kind of wrap up our book study here on the teaching channel, we just really had a few more questions that would really help us clarify really how we move forward from here and how we continue our implementation and development. So thank you.
You're welcome. We should have done this at 4:30 in the morning when I'm really sharp. I'm good for nothing after 2 o'clock. Let's go anyway.
All right, so let's get right into it. And I'm going to start off with our first question, which was, how can you get buy-in for our middle school and high school teachers? So far right now, a lot of our community that's engaged in our book study has really been at the elementary level at K-5. We've seen some 6, 7, and 8 teachers, but yet the question is really, speaking to those middle school and high school teachers, how can you get buy-in when it doesn't technically fit their standards?
Okay. First of all, let me say that I've done quite a few of the 2-day Number Talk Institutes where there are a lot of middle school and high school teachers in the workshops, and I haven't seen a resistance from them. I understand the resistance because they feel a lot of pressure to get through the curriculum that they're supposed to be teaching. But what I've heard consistently from people is that Number Talks is really powerful for revealing holes in students' thinking at the upper levels, and that teachers have sort of always known were there, but they're really there, and they show during Number Talks, and that Number Talks also provide a way to fill those holes in understanding by asking kids to bring sense making to working with numbers at whatever level they're working at. But if I were going to design, and I have designed sessions for middle school, high school, and even community college folks, I would tend to put together a session where I started with multiplication, and I started with a 2-digit by 2-digit problem, like 26 times 48, where I ask them to do it mentally. And the reality is that most everyone struggles to do so. And then I would share what students do with that, because there are lots of really efficient, easy ways to think about a problem like that once you learn to reason with numbers. And so after sharing different ways that students would think about it, I've tended to pose a problem. Let's stay with the what did I say? 26 by 48. I have to write it down. Yep. I can't hold numbers.
Let's go with that one.
At this time of night. So I might say, after that we've heard different ways that kids would do it or different ways that they have solved it. And if they tell you how they solved it, they tend to be very cumbersome ways that are harder than the ways that kids use. So after hearing from kids who said, well, I said 50 times 26 would be half of 2600 or 1300, and then I took away 2 26s, for example. Or I said 26 times 48 is a quarter of 4800. So it's 1200, but I need one more 48, so it's 1248. They have really efficient ways to solve problems like that. Then I would tend to say, what if we had a child who said, well, I said 25 times 40 is 1,000. And I said 25 times 8 is 200. And I said 6 times 40 is 240. Am I getting my numbers right? And 6 times 8 is 48. And I would just record that much of it and say, without giving any kind of guidance at all, I would say to people, you may have experience with this and you may not, but let everybody do their own thinking on this, please, and I'll tell you when you can talk to each other. I would just say, would you try to show geometrically what that student's way of thinking would look like? And they will struggle with that. But eventually they'll get to a place where you realize that you have a rectangle that's 48 by 26. So if I draw down the vertical column at 26 by 48, just roughly, it doesn't have to be exactly proportional, and make that rectangle, and divide the 48 into 40 and 8. Be following what I'm talking about here?
Yep.
And I divide the 26 into 25 and 1. And then I look at the 4 different regions in the rectangle. So one of the regions is 40 times 25, or
right.
1,000. And one of the regions is 25 times 8 or 200. And then we have 1 times, what did I do? 1 times 40 is 40.
Yeah.
I did 6. I said 6 when I really meant 1. 1 times 40 is 40, and 1 times 8 is 8.
Mm-hmm.
And if you add them all up, it's 1,248. And what I would do a couple of those until they're using those rectangles really efficiently, and they work no matter how big the problem is. And that was a real go-to method for a lot of my kids. It didn't matter if they were doing something like 347 times 2,568. Once they knew they could divide those numbers into chunks they could think about easily, that was the go-to method for some of my kids. But then I would say to the secondary teachers, the reason why being able to do that is so important is eventually they're going to be asked to solve a problem like quantity x plus 1 times quantity x plus 2. And we want kids coming at that level realizing that you've got a multiplication problem then. And one of the dimensions is x plus 1. And as you're saying that, you would draw that line of x plus what we'll call 1, and one of them is x plus 2, and you divide up the rectangle, and you look at the regions, and you end up with x squared, and you have 2x and 1x and 2. And so then I have taken them through the FOIL method, and we get the same results with FOIL, but I say that FOIL tends to obscure the relationships, whereas showing it geometrically really reveals the relationship. So they see x squared as a square, etc. Right. And then I talk about mathematicians have what they call a rule of 4. And they say you don't really understand a problem unless you understand it algebraically, numerically or tabularly, geometrically, graphically, situationally. And yet we're not giving our kids opportunities to really understand those relationships. We're teaching them tricks like FOIL that really end up with them thinking there are rules to be followed instead of relationships to be understood. So I think part of convincing middle and high school is you take mathematics that's important to them, where they've always seen students have failure, and you try to make the point that we're asking more of students, not less of students, but we're really asking them to see all of mathematics as understanding relationships rather than rules to be remembered.
And I think I wonder if sometimes our middle and high school teachers, they're trying to, so like elementary feels like that they can structure and sequence their number talks, and it's pretty, it connects with their standards. So even for myself, as a middle school teacher, I try to structure my number talks, obviously following my students, but that it somehow is connected to what we're doing that day. So for example, I've been doing, recently we've been working on division of fractions. So my number talks have been multiplication of fractions, because those aren't in my standards to teach multiplication of fractions, but surely many of my students don't understand all the different ways, like you just mentioned, of what multiplication of fractions, or even multiplication for that matter, really mean, and really can't see, really, and even understanding the division in any sense is challenging. So I've tried to connect, even though it's not in my standards, a number talk that supports the development of the standard I'm teaching.
So I rarely did that. What I did instead is to say there's a trajectory of mathematical ideas that I want my kids to understand. So if we're in subtraction, didn't matter if I was in middle school, and it didn't matter even when we taught the high school kids in the high school class that we did. We said we're going to start with subtraction of whole numbers, and then we're going to say what were the strategies that worked efficiently for subtraction, and then we're going to pose the question. So will those same strategies work efficiently for fractions and percent and decimals? Okay. So we're going to have them play around with problems that are fraction and percent and decimals, but only when they have strategies from subtraction that they can bring to making sense of that. Because the reality is the same strategies do work and work efficiently. But if there was one flaw in the whole idea of the book study, and this is picking one flaw out of what I thought was a fascinating study, mostly listened to on my part, it was that there was a new chapter every week, where I would have spent 6 weeks on subtraction before moving on to a new new operation.
Well, hence
high school, I would have started with really understanding subtraction of whole numbers before we went to subtraction of decimals and percents. But once you really understand the whole numbers, then going to decimals and percents is fairly easy. But what we went in the book study was 1 week on subtraction, and then 1 week on multiplication, and then a week on, so that coherence of building the trajectory of the operation over time got lost.
Right.
I sometimes did tie it to my day's lesson because it was just opportune to do that. I think I said in another talk we did that one of the teachers I worked with said that her students were missing a lot of problems on complementary and supplementary angles. And she realized it wasn't because they didn't understand the concept, they did. It was because they made errors in their subtraction. So she did number talks subtracting from 180 or 90, just so that that wasn't the inhibitor of them being able to be successful with those problems. So sometimes I did time to the lessons. For the most part, it was 15 minutes separate that was building that trajectory of a mathematical idea.
Makes sense. Totally makes sense. So then the next question that really came up was
next question. Can I just say, I think when you're working with teachers, I think the really important thing is to give them experiences where they see that number talks are an answer to an age-old problem they've had, which is students coming to them with gaping holes in their understanding that's inhibiting them from being able to do the mathematics that they ought to be able to do. So they have to see it as a good thing that we're going to invest this 15 minutes a day to really build that foundation that kids are missing. I don't care how old they are. If they don't have that foundation, we're putting band-aids on a building that's going to continue to crumble.
So it's funny you should say that, because at conferences, at student-led conferences, my students led their parents in a number talk. And the most common number talk, and I gave them options that they could choose, and that they did it for their parents first. And then their parents wrote down what they heard them say. They kind of walked them through. And then the parents, and then the student did it back to the parent. So they asked the parent, like, what could you think about strategies to use? And I was just a bird on the, I was just walking around because it was student-led conferences. And the main question that students posed was 70 minus 39. That's the main one the parents tried out. And, no, excuse me, 71 minus 39. And at nearly every parent, or most, let me say over 50%, got 30 as that answer, and never questioned that 30 would never make sense.
Wow.
And it became more apparent, and I mean, I have some amazing, fabulous parents. And I didn't step in on that conversation at all. It was more just great formative data that reminded me that these parents have graduated high school, college, and yet here with a very simplistic subtraction problem that, thinking about it as distance, is, answered very quickly, was not attainable because of some lack of understanding about subtraction.
Exactly.
So,
and I
realize about meeting people where they are, as opposed to where I want them to be, is a constant reminder for me.
Yeah, and I started teaching in 1971, which feels like eons ago. And the whole time I've been teaching, high school teachers have told us kids get answers to multiplication and division that are off by 10 and even 100 times too much, and they don't even notice because they're trying to follow a procedure and not looking at all at whether what they're doing is resulting in anything that makes sense. So I don't know how many more decades we have to do this before we say there's got to be a better way. And I think talks are an answer to that issue.
Okay, so now let's move on to this one about kind of this data and research question, which is for people that are skeptics that are saying, well, I don't really know why I would do this. Where's the data that shows me that there's any benefit to number talks? What's out there in terms of data or research that we could pull on when we're trying to talk to colleagues about why it might benefit them if they're not in line with our ideas but need something more to convince them to try this?
Okay, I have to start by saying I always wish those same people would ask, what's the evidence that teaching standard paper and pencil algorithms to kids works? Because we've got decades of evidence that it doesn't work. And so why, when we try something new, are people saying, prove it, prove it, prove it? I don't really, I guess I understand it, but it makes me sad, because how long do we have to have mathematics education that most students say no thank you to before we say there might be something better? Having said that, I think number talks is an area that's ripe for research. I have tons of anecdotal evidence, because I've been working with teachers over quite a few decades now, and they write me and they talk to me about breakthroughs that they've seen in their students and in their own understanding of mathematics. And you saw that during the book study a lot, teachers writing that they were learning so much with their students. But the reality is that there isn't a lot of finished research. I know myself personally of 3 different doctoral studies that are being done on the topic of number talks right now, but they are not published yet. The research isn't finished. So we're in an interesting place where there may be research. I don't know of the research. I do know of lots of teacher-reported findings, but that's not going to satisfy people who are saying research. So I think the best we can do is to say, we have decades of research of what isn't working, and we have preliminary evidence of what is working, but we're waiting to find out. And there are, I'm sure the 3 studies I know of aren't the only studies going on right now, because number talks is a topic a lot of people are interested in learning more about. And I do think I'd encourage anybody who's a researcher to pick it as a research topic. I think there's a lot to be learned.
So it seems to me like kind of the, without saying this to somebody who's a skeptic and pushing them completely away, but it seems like, you know, that definition of, is it insanity that's doing the same thing over and over again and expecting different results, really starts to play into effect here, which is year after year after year, many of us math teachers are having some complaints about, like you had mentioned, about the holes that our students are having or what's wrong with them, and still doing the same thing. And maybe it's not exactly the same thing, but in principle, it might look a little different, but it's, you know, based off the same, you know,
ideas. Doesn't look, especially when you get to the upper grades, very many places it doesn't look very different from how it's looked for decades.
Yeah, and so
in terms of when it comes to teaching, the teaching of arithmetic, it really doesn't look much different.
Right. So that seems like just like a natural, I can kind of see where you're coming from. Of, we don't have anything yet that suggests that this is, you know, in terms of formalized research, but we do have a lot that says that what we're doing is really just going to create more, you know, frustration in students and teachers alike, parents as well.
Well, and there is research to draw on. It doesn't happen to focus on what we call number talks. But if you look at the TIMS studies, especially the Third International Math and Science Study, where they did all the videotapes, if you look at videotapes in Germany, those students are doing math in their heads. They're doing mental math and using different ways to solve problems. If you look at the TIM studies again, when they look at the difference between the top performing countries and the US, the top performing countries are really focusing on conceptual understanding. Are they really understanding the relationships? Well, I think number talks are all about students using the mathematical relationships versus just learning procedures to follow, whether they understand them or not. So I think there's a lot. I'm not saying there's no research out there. You asked specifically about research on number talks, and I think there is a lot of research that backs up the kinds of thinking and reasoning that we're asking kids to do during number talks.
And so this is just because I'm a novice, you know, in this area. How would I access those TIM studies? Are those readily available to me?
Google it. TIM, Third International Math and Science Study. It's now called Trends in International Math and Science Studies. Jim Stigler at UCLA was he's written a lot on the topic, and it's fascinating stuff. You're right, it came to prominence a few years back and has faded from view for a lot of us, but it's worth digging up again.
Okay.
There's a terrific,
I think that would really help.
Yeah, there's a terrific there's a terrific article on research that Jim Hebert did in, trying to think of which research journal it was in. I think Journal for Research in Math Education. I'll try to dig it up and give it to you. I can't tell you the name of it right now, but if you—
Yeah, if you do, let me know and I'll put it in our blog post.
If you Google Jim Hebert and research on math education, it'll probably get you to that area. Alan Schoenfeld at UC Berkeley has done a lot of research on students thinking around mathematics. And so, it's easy to point people in the direction of research that supports the kind of changes we're talking about. I just don't specifically know of results on number talks.
Okay, perfect. So then, now going back to so somebody who is using a number talk, and we're seeing a bunch of different strategies that are taking place within the classroom. And this question of when do we, as teachers, is there a place? So first of all, when or if, is there a place to start this discussion of efficient strategies? Is that within a number talk? Is that outside of a number talk? Is that at all? So when is this a question of efficiency and having that dialogue with students? And then secondly, I think the second question I want to talk about is if that is something we should or would be doing, how would that look?
Okay. So first of all, let me say I would never, ever, ever ask kids to vote on most efficient strategies. To me, that's a deal breaker in terms of convincing, especially shy students, to invent new strategies, which is what we're really trying to get at, is kids learning to have mathematical ideas. But there are some things I would do. So if I was doing a number talk and thumbs weren't coming up for a long time, I would suggest that to students that what they're trying might be cumbersome. And a good place to start is to back out of that and to look at the numbers and say, how can I turn this problem into an easier problem to solve? And then I would give them more time. But I'd say, start by backing up and really looking at the numbers and say, what can I do to turn this into an easy problem? I used to use efficient. Kids tend to not care about efficiency, but they care about easy. So interchange that language with them. And sometimes if I gave kids a challenging problem, I would ask before asking who wants to share, I would ask, did anybody use a strategy that you thought was really efficient or easy to use on this problem? And I'd listen to that student's explanation, and then I'd ask, did anybody else find a different strategy to be really efficient or really easy to use? And I'd continue to ask that question. I wouldn't expect or ask kids to try those strategies next, because I know that over time kids gravitate to the strategies that are most efficient. But I also know that efficiency lies in the mind of each individual learner. I know Kathy and I wrote in the book that nothing's efficient if you don't understand it. So our job is to nudge toward efficiency. But I think, ironically, asking kids to judge the efficiency of one idea over another is counterproductive in terms of building efficient strategies. So we want kids to hear from each other about things that worked efficiently, but not to sanction one strategy over another. And I think we want to trust that over time they let go of their cumbersome methods when they hear better ideas. But we don't want them to say good idea because a teacher said it's a good idea. Our goal is for a child to say good idea, I could have tried that idea. And then our job is to give them another related problem so they can try something that they might have heard from the problem before. I think that's one of the reasons why we've said to people for a long time that if you would commit to doing a 15-minute number talk once a day for 2 weeks, you'll get a whole lot farther than if you do it once a week for 2 or 3 months, because it's almost impossible for kids to remember an idea they heard a week ago. And what we really want to do is for them to hear an idea, be able to test the idea, and be able to do it often enough that it becomes efficient for them. So efficiency comes from practice.
One of my favorite things is, without prioritizing it or saying anything, is when within a period a strategy becomes like, this is Max's strategy. Mm-hmm. And then the next 2 weeks, every other kid is trying to use Max's strategy. Yes. And then Max comes up with a different strategy because he's tired of everybody using his strategy. So he comes up with a new strategy. And it's just one of those really organic things that starts to happen where students hear somebody else and then other students don't. And I know that, what I know at that moment is it's really interesting because I've been having a lot of conversations lately with my administration about what happens when students don't share. And I'm more and more convinced that when students feel comfortable and ready, they will. So some won't, but generally speaking, in my grade level, which they're 11 and 12, they, when they feel comfortable, they will. So this is interesting. It's been really interesting I guess efficiency is sometimes a breakthrough for one student, or what's efficient to one is completely different. And for me to make an assumption, may or may not be right. And I don't know that I really want to test out that, probability.
Yep. There are some things you can do sparingly, I think. If you know that a method is particularly efficient and you don't see your kids gravitating to it, then I think it's really great it's fine sparingly to say something like, Crystal added 2 to both numbers. She just shifted those numbers on a number line, and I want you to investigate whether that method's always going to work and why or why not. And you take Crystal's idea or whoever's idea and you turn it into a mathematical investigation, because the mathematics underneath that is worthy enough of us spending some time on it. That doesn't usually rarely happens in the moment. And one of the things I've asked kids to do at the end of a number talk is, I would share in this case, so I want you to think tonight about Crystal's strategy that she used and whether it's going to work all the time or not. So write it down in your journal and come ready to talk about your thinking about it tomorrow. And then tomorrow we launch into an investigation, like we wrote up in the chapter on sometimes a number becomes a lesson or becomes an investigation.
Okay. And then we had a lot of primary teachers join us on this book study. And obviously the intent of the book wasn't written with them in mind, but they could access the strategies and many of the operations as well. And so from some of our primary teachers, they wanted to know if there would be different advice or what advice you might be giving them as they engage in number talks.
I guess the first advice I'd give them is try to get their hands on Kathy Richardson's videos. I think they're called Thinking with Number Talks, and they're on her website, mathperspectives.com. And you'll see kindergarten, first, second, third graders doing number talks. But one of the things you see that's different there, first of all, they're going to spend in kindergarten, first grade, they're going to spend a lot more time on the dot cards than we do, because they're really trying to build fluency with small numbers there. And you'll also see kids sitting on the floor with Unifix cubes or something that's break apart model, not Dean's blocks, because not the place value blocks, because they don't let kids, you can't break them. So kids can't think about it in their natural ways. But if you used Unifix cubes or interlocking cubes, what you'll see Kathy doing is she'll put a number on the board like 23, for example, and ask kids to build the 23. And she says she does that because that helps them develop a sense of quantity of the number. So they're building 23, and then she puts the problem up 23, take away 8. And she says you can either think about this or you can solve it with your materials. And she gives them time to solve it and put their thumb up. And then she asks them to share how they thought about it. And I'll never forget the first time I went in with teachers that we had finally convinced to just see what children do naturally with numbers. And the problem was 23, take away 8. And there's a little boy who had built his 2 10s and his 3. And when he said how he solved it, see if you can follow this. Okay. It was 23, take away 8. He said, I broke 8 off a 10 and I moved the 2 over with the 3. So I had 1 10 and 5, and that was 15. I didn't follow that. And I said, could I hear that again, please? And he said, yeah, I broke 8 off of a 10, took it away. And that left me with 2, and I put that over by the 3. So I had 1 10 and 5, so it was 15. And I thought, oh my gosh, we've been teaching kids, take one of those 10s, break it up into 10 1s, move it over by the 3, and now you've got 13, and now you can take away. Why in the world would a child do that with? And they can just say, I can take 8 off of this, and then here's what I have left. So it was stunning to me to see what happened with little children when we stepped out of the way and asked them to make sense of the numbers. So I think you see manipulatives, whereas when I'm working with older kids, I just tend to have naked numbers as the focus. Mm-hmm. And other than that, number talks look a lot alike.
I know, as a mom of a kindergarten son, I know when he was, first starting to think about numbers under 10, I would start to say, how can you make 6? And, my son would say something like, he would get out his fingers and, he would be counting the back seat and he would say, well, 5 and 1. And I wouldn't, respond with yay or good job. I would just say, is there another way to make 6? And he would say 4 and 2. And then is there another way? And he would say 3 and 3. And I'll say, is there another way? And my son started to really at a young age have flexibility of numbers.
Yeah. Yeah. Kathy's work is really beautiful that way. There are other people that have really nice work also, but Kathy Richardson's work with developing math concepts. It was first called Developing Number Concepts Using Unifix Cubes, but now it's been broken into 3 Developing Math Concepts. Just really, I wish she'd rewrite it for parents, because there are just lovely things. Like everybody at the table has 7 cubes hooked together if we're working on 7, and everybody hides some behind their back and opens their hand, and the whole family reads 3 and we anticipate what's behind the back. So 3 child brings out and it's confirmed, yep, 4 are there. Or we have a bowl and you put a few on top and we're saying 2 and we're anticipating what's under there. So 5, and she lifts the bowl and yep, 2 and 5, but mom's done 3 and 4 and dad's done 1 and 6. And so we're looking at physically lots of ways that you can make 7.
I love that idea. We're doing that in my house next week.
Yeah, it's a great resource for early number.
Okay, great. So then, so perhaps that kind of goes along. So the next question that somebody asked was, if you were to walk through like a first grade classroom and observe a number talk, what would you hope to see or hear? And you did mention that you would imagine that you would probably see something that they could break apart, and that would be sizes that were all consistent sizes.
Yes, and I'd see some kids using the materials, and I'd see other kids looking at the numbers, and you can just see their little brains working on the numbers without the manipulatives. So they're there for whoever needs them. What I saw in one of the videotapes was a teacher say, if you need the manipulatives, you could use them. If not, just solve them. I wouldn't use that language. I would just say you could use the manipulatives, or you can just think about it. It's up to you. I don't want to make it sound needy if a first grader is using manipulatives, because it's very appropriate for them to be using manipulatives. They'll give them up when they don't need them anymore.
Okay, so that's a really fine clarification. So remind me. So
I wouldn't use the language. Yeah, I wouldn't say if you need the manipulatives, you can use them, because that implies you're needier than some of the rest of us. I would say you can use the manipulatives for this, or you can just think about it. It's your choice.
Wow, that's a really, I get what you're saying. It's a really fine, minor change in language.
It is. It's not a huge
access or doesn't.
It's an implicit message we're giving to kids. It's really important here.
Wow. So
I'm trying to take off the burden of needing the blocks. That's right where I need to be. And if I didn't need them, I won't use them.
Agreed. Okay, that makes total sense to me. All right. So as our primary teachers are thinking about coherence into the upper grade levels, whether that be, just upper elementary, middle school, or high school, this question came up about thinking about negative numbers and what could first grade, like in our K2, so what could K2 do to help our students develop an intuition about negative numbers before they encounter them?
Okay, so I have to honestly say, when I first saw this question, I thought, why in the world would you ever want to do this? I'd be happy if first graders left first grade really fluent with numbers to 10. And they aren't. My kids were coming to me as fifth graders, not really fluent with numbers to 10. So I think I think we have to be really cautious that we don't push more abstract ideas down earlier into the grades at the expense of building the real foundation for being successful with number. Having said that, I think the investigations in number, data, and space program did some interesting work with third graders around negative numbers. And I think they used the model of being in an elevator, and the elevator, like if they were in the elevator on the 3rd floor and they went down 4 floors, where were they? So that it was the idea of being in a basement, which was below ground level. And it was really interesting to watch that third graders would often deal with negative numbers naturally. And at the same time, I saw 6th, 7th, and 8th graders, once we taught them, be totally confused about negative numbers. So with first graders, I wouldn't ever push for it, but you'll occasionally have a child that uses it. I had a little boy named Keith Ledford who came to me as a first grader reading the Hobbit trilogy, which was frightening, but he needed different things than my other kids. So if Keith had in solving a problem like 13 minus 8 said he took 8 away from 3 and got -5, I would be surprised, and I would ask him, how did you think about that? But I wouldn't focus on it or expect other kids to take it on. Other kids might take it on, and it's delightful if they do. But I don't see it as a core idea that I'm responsible for. What I am responsible for is not teaching something that is not true. And I have to say, I taught for quite a few years saying to kids, you can't take 8 from 3, so you have to go over to the 4 and borrow 10 from it and make it a 3 and move the 10 over by the 1 and make it a 13. We don't want to give kids rules that are going to become not true so that they think that math is arbitrary. And I think, excuse me, can you turn that camera off for me for a minute?
Well, I don't, you just gotta get out of that. Yeah, just,
okay.
I can't stop it, but
That's okay. Just.
But you can get up and walk away at any point you want.
Joke up here. Where was I?
Third graders, and the kid was reading The Hobbit, and that a general idea that if, that our job is not to teach, well, I'll take it on. I'll take it back to me.
I think I was talking about one of my main problems with the standard algorithm, the standard paper and pencil algorithm, is that in teaching them, we teach kids things that are just not true. And we obscure place value, and then we wonder, why don't they understand place value? And if you just thought about just subtraction, how many of us have taught kids, if you're doing 13 take away 8, kids say you can't take 8 from 3. Well, of course you can take 8 from 3. And so we're going to have to borrow from, well, we're not borrowing because we're not paying anything back, and we're not making a 5 a 4. We just teach it as if it's procedures, and they're procedures that mask place value and that teach kids things that just plain aren't mathematically true. So teaching a rule that's going to become not a rule in the long run. It's like kids think that math is arbitrary. Depends on who's teaching to when. So I think it's important for the teacher to know the trajectory of where ideas are going, so they don't teach in ways that interfere with that trajectory. But in terms of caring if my first graders can deal with negative numbers, I don't really.
Right. You know, and it reminds me, you know, just a few years ago, I made a huge shift in my practice, which was, I remember working with, you know, like my highest level kids and thinking that what it meant for me to service them was to give them the next year's standards. And that meant that what dynamic of an instructor would I be if I gave them the next year's standards? And I've often been reminded that, you know, and especially now, I mean, there's a lot of thought and intent put into the Common Core standards. And, you know, there's so many rich ways that I can encourage a student's depth of thinking by staying within the standards that are developmentally appropriate. And I've confronted that a lot. I've also confronted really recently, it was recent. I wish I could think of the exact thing I was saying, but I went to say something as I was just in the middle of, you know, this kind of going back and forth with students and them talking about a strategy. And I was kind of making sense of their strategy as a learner in the classroom. And I said something just kind of to myself to them, but also to myself as I was processing out loud. And it was a statement that as I said it, I was like, well, that's not always true. And it was a moment where more and more, the more I teach math, the more I'm confronting things that I didn't even think were tricks, that are still tricks. And it's just more, and it's at times it's really unsettling to me because it makes me feel like maybe I don't know as much as I thought I knew. And that's something.
Crystal, I've developed a philosophy that says if you ever think you've arrived, you're undoubtedly in the wrong place. So it's always going to be a journey, and you should learn to enjoy the journey. But I'm also reminded of 2 other things. And one of them is Phil Darrow I was at a Silmar this past weekend, and I went to a talk that Phil Darrow did, and he talked about working with some folks in Japan, and he said they talk about teaching on the horizons, that you can look at the horizon behind you in terms of, and his analogy was looking at where our kids have come from, but you teach holding in sight the horizon in front of you. And I think in order for a teacher to be able to do that, we as a profession need to find ways to give teachers real sustained opportunities to deepen their own understanding of mathematics, not by sending them to university courses where they're going to be taught math in ways that were crippling to so many of us, but by letting them learn mathematics in environments that fully model what we want classrooms to look like for all kids. And the other thing that I'm reminded of when you said you thought you were doing a good thing pushing them to the next grade is Walter Denham, who's no longer alive, but he was a dear, dear man in charge of math and science for a number of years in California. And I remember Walter saying, if you're talking about mastery in mathematics, you're talking about the trivial aspects of mathematics. The really important ideas are never fully mastered. They deepen in complexity over time. And I every time I hear somebody talk about mastery in math, it's literally like fingernails on a chalkboard for me. And I think that oftentimes when we're putting them to the next grade standards, math ends up being a bunch of isolated pieces on the floor that kids can't tie together or see as interrelated and can't use. And it comes back again to me, to teachers needing sustained opportunities to learn, so that at whatever standard you are teaching, you understand the depth of that mathematical idea and you're able to pose questions that allow students to probe deeper. And I think you experienced that in our workshops that we put together in our project, that a lot of you came in pretty confident that you knew the ideas that the workshop were designed around. On day one, found some holes in your own understanding and then watched yourself fill those holes over time. But we had elementary teachers through university mathematicians in there learning all together. And that's the beauty of the mathematics. If you're really focused on what are the big ideas, they are deep and can be ever deepened if a teacher knows how to ask a question that gets kids to probe deeper.
Right, and I think I've redefined like what success looks like for me, because since I now have learned that I'm still developing my ideas, which is hard to grasp as a teacher of mathematics, because when I first entered the field, it felt like the expectation was of me to be more of an expert role. And now I think that really the sense that I'm just evolving as a learner myself is really so I guess now the awareness that I don't actually know it all is what I deem as success. So now I've looked back at myself 5 years ago and think I never second guessed so much of my practice then. And the fact that I do now, though it can be really hard at times, because sometimes I'm much more self-critical than I ever was before. Mm-hmm. At the same point, it's also very successful for me that, because I feel like now nothing goes in without really intentional thought and reflection, mm-hmm. and good or bad. And that self-reflection is just really important, whether that's in a number talk or anything within my classroom. So. Yeah.
You remind me of a middle school teacher who wrote to us on day one of a workshop that we designed so that teachers would confront their soft spots. At the end of day one, he wrote, my whole identity as a teacher of math is that I know my math well and I can convey it to my kids well. And now I'm seeing that I have a really fragile understanding of ratio and proportion, and it's not a comfortable place to be. He went back to his classroom and he wrote us about 2 months later, and we call it the liberation of, I'll call him Derek, his name was not really Derek, but he wrote about how he and his kids had both come to a place of viewing disequilibrium not as something bad, but as standing on the precipice of learning something new. So it's a very exciting place to be. So they've come to embrace their disequilibrium instead of running from it, which I thought, how beautiful. That's really where we want to get all kids, is knowing that when they're confused or when they're in cognitive dissonance or when they're in disequilibrium, that's a great moment, because that's really where learning happens.
Right. Well, first, to wrap it up today, Ruth, I just want to say on behalf of myself and everybody else at the Teaching Channel, so much of us thinking about this book has also been hearing from you. And so really, thank you for taking the time out of your schedule to talk to me more than once, to chime in when other people said stuff, and to push back against us, and to kind of and model that openness in yourself as well. So thank you so much for giving such a book that allowed so many of us to think about math in new ways and give our students access to ways that we had not had access to before or had not fully developed before, and that we're just continuing to develop. So, really as we wrap up the book study on the teaching channel, just a huge thank you from all of us to you and to Kathy as well.
Let me just respond by saying I got a whole lot more out of this book study than you got from me in the book study. I wish I could have been more fully participating. I was kind of in over my head writing proposals to keep our work in Washington going, which is a worthwhile thing. But whenever I did get to be online, it was just wonderful. Every time it was like putting a down blanket around me on a cold morning, listening to teachers talking about how much they were learning with and from their kids. And so to me, having come up with this idea 30 years ago, to see it and watch it, watch the conversations that are going on, not only all over this country through the book study, but in other countries, has been really amazing. And Crystal, I cannot imagine being you as a full-time teacher and all the moderating you did to respond to people all along the way. So let me just say thank you to you, but also thank you to everyone else out there who was brave and courageous enough to share their struggles and their successes and their breakthroughs. And I continue to believe that if we could get enough people to make this shift in their classroom, we will change the world, because kids will learn that they're havers of mathematical ideas. Teachers will learn that they're havers of mathematical ideas. Kids will learn to listen to other perspectives. And I just think that's a recipe for a far healthier nation and healthier kids. So keep going, teachers. Write to me once in a while and tell me how things are going.
Well, that sounds like just the perfect place to end this, Ruth.
Okay. Well, let's end it.
I'm going to stop the broadcast, but it's not going to hang up from you. So you stay right there. I'm just going to stop the broadcast.
All right.